Polyhedron. Poly meaning many. Keep that in mind as we do this. A polyhedron is a solid that is bounded by polygons. We talked about what polygons were last chapter. You have trapezoids, you have rectangles, you have squares, you have triangles. All of those are polygons. Pentagons, hexagons, octagons. The biggest thing about polygons, reminder, is that they're formed by straight lines. They're formed by line segments. They're not rounded. A circle is not a polygon. Okay? So a polyhedron is a solid that is bounded by polygons. And you see an example of a polyhedron over there. That polyhedron looks like it's made up of 2 trapezoids and 4 rectangles. Okay, all the sides are polygons. All the sides are called faces. And so a polyhedron is a solid that is bounded by polygons called faces that enclose a single region of space. An edge, think about falling off the edge. We all know what an edge is. An edge is the line segments there on the corners or on the edges. An edge of a polyhedron is a line segment formed by the intersection of 2 faces. A vertex is a corner. We all know what the vertexes are. A vertex of a polyhedron is a point where 3 or more edges meet. The plural of polyhedron is polyhedra or polyhedrons. You can say it either way. Decide whether the solid is a polyhedron. If so, count the number of faces, vertices, and edges of a polyhedron. Okay, here we go. The first one, Riley. First off, is that a polyhedron? Are all the faces, pretty much is what you're asking yourself, are all the faces polygons? Yeah. Yeah. Now, next step, Hunter, how many faces are there? 5. Let's see, faces. Oh, you're right. There are 5 faces. Edges and vertices. Let's do vertices next. Vertices, edges. Matt, how many vertices are there? 6. And Briley, how many edges are there? 9. Let's see. 1, 2, 3, 4, 5. Is there 9? Yeah, I didn't count the top one. 9. Second one. Dylan. Oh, there's just one Dylan here today. Dylan, is that a polyhedron?
Yeah.
Is this a line? Second. Here. That's a curve, isn't it? Anytime you have a curve, it's not a polyhedron. Okay. That's looks like it's part of a cylinder. That looks like, remember doing sectors? To me, what that looks like is it's a sector of a cylinder, a 3-dimensional sector. If you took this sector and you kind of brought it straight out from the board, you cut it out. Well, imagine this is the top of a Coke can, and you cut this section out. That's what that reminds me of. Okay, if the Coke can was solid. There we go. Cake would probably look better. That's a slice of cake. And the last one, trace, is that a polyhedron? All straight lines? Yeah, we're good with that. Faces, vertices, and edges. This one will be a little bit tougher. Faces, vertices, edges. Alex, how many faces are there? Let's see, you've got 1, 2, 3 on front, 1, 2, 3 on back, and the bottom. That's 7 faces. Good job. How many, Carly, vertices are there? How many? 7. I got 7. And finally, how many edges are there? Jagger. Can you count edges from there? How many? I don't know. You got 1, 2, 3, 4, 5, 6 on bottom, right? You've got 7, 8, 9, 10, 11. I got 12. Not really, just backwards. Yeah. 21, 12. There you go. Now I do want to show you this. This is what Euler's formula. This is one of those extra information. That's kind of like the Heron's formula I gave you last time, Euler's formula. Here's what it says. F plus V minus E. I want you to see the relationship between your faces, your vertices, and your edges. Take your first problem. Add your faces and vertices and subtract your edges. What do you get? 2. Take your last problem. Add your faces and vertices, subtract your edges. What do you get? And it will always equal 2. The faces of a polyhedron plus the vertices of a polyhedron minus the edges of a polyhedron will always equal 2. Now, could you use that on your homework? Yeah. Because once you find faces and vertices, you know how many edges there are. So let's say I have some shape that has 7 faces and it has 9 vertices. I don't know if that's an actual shape, but let's just go with it. It has 7 faces and 9 vertices. Can you tell me how many edges it has? 7 and 9 is 16, so it has to have 14 edges to give you the 2. That makes sense. So Euler's formula says faces plus vertices minus edges will always equal 2. Here's a list of pretty much what you're going to be doing the rest of the chapter. Of the 5 solids below, the prism and the pyramid are polyhedron. The cone, the cylinder, and the sphere are not polyhedron. Now, what's special about these shapes? These are your common 3-dimensional shapes. These are actually the shapes that we're going to be spending the rest of the chapter on. We're going to be finding the surface area, the lateral area, and the volume of these shapes. And you know what? While we've got them up here, let's talk about those 3 things. Surface area, lateral area, and volume. Now, last chapter we talked about area, and we talked about perimeter. And kind of the same thing going on here. There's 2 different types of measurements here. The same way that area was how much space was covered by something. Like you wanted to lay carpet, you wanted to put down tile, you wanted to paint a wall, you wanted to cover a surface with something. That was area. Well, you wanted to build a fence around an area. That was perimeter. You wanted to put chair rail or crown molding up around the room. Anytime you were going around a shape, that was perimeter. Anytime you were covering shape, that was area. Surface area and lateral area kind of picks up from there. Let's say that you've got a prism, like you've got here. You've got a prism, and what you want to do is you actually want to cover that prism with paint, or you want to cover that prism with carpet for some reason. Wrapping a prism would be a good example. If you want to wrap something, you want to put some sort of surface all over this, that is a surface area. To find surface area, and this will, honestly, if you understand what I'm about to say, this chapter might be pretty easy too. To find surface area, well, this first polyhedron here, this first prism, has 5 surfaces, has 5 faces. Everybody see that? If you find out how big those 5 faces are and add them together, that's your surface area. That makes sense. That's the area of all the surfaces. Let's go to lateral area. What if I want to find the lateral area? Does anybody know what a lateral or lats are? The sides, right? When you're looking for the lateral area, you're not looking for the whole surface area. You're looking for simply the area of the sides. So with this first one, if I'm looking for the lateral area, I'm ignoring the 2 triangles, and I'm simply finding the area of the 3 rectangles. Same way down here, the cylinder. If I'm looking for a lateral area, I'm only concerned with the side. I'm not concerned with the top and bottom. Now, why would we need to find a lateral area? Well, sometimes you just need the area of the side. What if this is a toilet paper roll, and you want to paint the outside of it? I don't know why. You want to paint the outside of a toilet paper roll, and you need to know the area to know how much paint you use. Well, there's no top and bottom. You need the lateral area. You don't need the surface area. Now, volume. Volume kind of goes along with area. The area is how much it takes to cover something. Volume is how much it takes to fill something. how much space is inside of a container? You wanna pour something into a container. You want to fill it with something. Okay. You want to see how much air it takes to fill it. That would be volume. How much containment there is in that shape. Okay. So that's what we're doing in this chapter. A polyhedron is regular. We already know this. Regular means all the angles are the same, all the sides are the same. Same thing here. A polyhedron is regular if all of its faces are congruent regular polygons. Notice here, regular, because all four faces are the exact same. You see the tick marks. They're all equilateral triangles. So therefore, that's a regular polyhedron. A polyhedron is convex. Let's talk about concave versus convex again. Last chapter, that was a convex polygon. This was a concave polygon because it is caved in. It's the same thing with polyhedron here. You have convex here versus yeah, see where it's caved in here? Concave. Oops. Concave there. Non-convex is what they actually say instead of concave. A polyhedron is convex if any 2 points on its surface can be connected by a segment that lies entirely inside, or that's confusing. Y'all see the difference. You see the difference. Next up, is this octahedron? The reason they call these octahedrons is because they've got 8 faces. Y'all see the octa meaning 8, like an octopus has 8 legs. Is the octahedron convex and is it regular? Goes away, but we think about the first one. Well, never mind. I've got the answers here. The first one is convex because it does not cave in anywhere. Okay, there's no dents in this shape, and it is regular because notice all the tick marks. Everything's the same. All the sides are actually equilateral triangles. It's an octahedron with all equilateral triangle sides. The second one is convex, but it's non-regular. It's not a regular polygon because this face and this face look absolutely nothing alike. In order to be regular, all the faces must be the same. And the last one is non-convex, which we can also call concave because look at this big dent in it right here. Somebody hit it with a ball bat. And it is non-regular because all the sides are not regular polygons that are identical. Cross sections. And this first part of the chapter is pretty much just getting all their vocabulary out of the way. Imagine a plane, not an airplane, but a mathematical plane. Imagine a plane cutting through a shape. The intersection of a plane and a solid is called a cross section. For instance, we see here a cross section of a sphere. The diagram shows the intersection of a plane and a sphere, which is a circle. And let me show you, I found a good website that shows you some pretty good three-dimensional cross sections. Here you've got a cone. And this is pretty cool because what it does is it shows you the three-dimensional shape. And when we say a plane is intersecting it, here's the plane. The plane's coming through in this direction. Let's switch it to where, let me go to, if I can remember how to reset it. Here we go. Reset the cone. Let's slice it. You see there? They're slicing it straight through, and you can take and you can rotate this thing. This is the plane. Okay, let's say that a plane has come through a flat surface and is sliced through this direction. Well, here shows you what that cross section would look like. So if you took a cone and you intersected it with something that's parallel to the base of that cone, you end up with a circle. Well, what if I slanted that cross section? What shape do you think you would have then? You see that? It's called, most of the time in math, it's an oval, or sometimes in math we call it an ellipse. So if you cross section it at an angle, you see there the cross section? A cross section of a cone at an angle would be an ellipse. Now let's look at cylinders. Same thing with a cylinder. There you go, 90 degrees. If it's parallel with the base of the cylinder, reset it. Parallel with the base of the cylinder, you've got a circle. But as soon as you tilt that, it's an oval. Okay, if you tilt it enough, it's actually this funny looking shape. You see that? If you tilt it enough, it's a square. If you took a Coke can, or actually rectangle, it'd be a square if the diameter were the same as the height. It'd be a square, which looks like it here. But all depending on how you cut it, because we could actually have this funny looking shape, right? If we cut it at a bad enough angle. So you would have this kind of arc with a flat bottom. You know. Let's look at a pyramid. Let's cut it flat. This is a pentagonal pyramid. The reason we call it a pentagonal pyramid is because the bottom's a pentagon. Pentagonal pyramid, if you cut it parallel to the bottom, you would have a pentagon. Would be your shape. If you slice that, if you turn that a little bit more and just extend that pentagon, with me there. Last one, let's look at a prism. Same thing you got going on. This is a pentagonal prism. The reason we call it a pentagonal prism is because the bottom, again, is a pentagon. If it's 90 degrees, notice your cross section would be a pentagon, just like the bottom. But the more that you slant it, it's just going to take that pentagon and extend it. Let's see what happens when we extend it straight up and down. It's a rectangle. Makes sense. Let's see, if we've done all of them, double cone. Now, I'm getting ahead of myself. I pulled this actually off of a calculus website. When you get into pre-calculus and calculus, you start talking about what's called conic sections. Some of your conic sections, like I said, I'm a little bit ahead of myself, but that's all right. Some of your conic sections, let's see if I can slide that up and down. I don't know how to. There we go. Your most famous conic section is a circle. Your conic sections, when we get into pre-calculus and calculus, your conic sections are, if you had a double cone, and this is what a double cone looks like. You've got a cone on top of the cone. Okay? If you took that double cone and you just sliced it in different ways, sometimes if you slice it, you end up with a circle. Sometimes when you slice it, you end up with that ellipse we were talking about. There it is. It kind of stretch it out a little bit. Sometimes when you slice it, you end up with a parabola. You remember talking about parabolas? Yeah. And sometimes when you slice it, you end up with what's called a hyperbola. And again, that's something that we'll get into later on when we start talking about conic sections in your other classes. But back to what we were doing. Here. So that's what a cross section is. Describe the shape, and here they're wanting you to imagine the cross section. They took a cube. Describe the shape formed by the intersection of a plane and a cube. The first one, now if it's a cube, careful, it's a cube. The first one will be a square. If you go you go parallel with the base, which would be horizontal. You do a horizontal cross section, it would be a square. Now, what about this? I'll make you think a little bit. If you took any shape, take any shape, whether it be a cone, a circle, and just give you something to think about. If you do a cross section that is horizontal with the base, that is parallel to the base, will that cross section always look like the base? It'll at least be similar. Because a cone, imagine taking a cone and taking a cross section here, it would be a circle, right? So it would look like the base. It won't always be exactly the base, but it'll always at least look like it. The square, like we had there, you've got the square is the same as the base. If you took a sphere and you did it horizontal to the base, the sphere doesn't really have a base, but it'd be a circle again. So yeah, possible. Second one, you took the cube and you ran it at an angle now. What do you have? Pentagon. Okay, you see the purple pentagon in there. And then the last one, you took it and you just cut a corner off, right? So what shape you have there? You see the purple triangle. We cut off a triangle right there. Any questions about what cross sections are? Let's look at these other four. And the second one's kind of the scenario that I just gave you. First one, you got a sphere, cross section. End up with a circle. Right? Will it always be a circle? What if you angled that? What if you angled it down through? Well, not necessarily there. Could you ever have an ellipse there? Yeah. Yeah. Second one, you got horizontal to the base. You got a circle there. Third one, is this now? I'm glad you said that. Now you got me started thinking. Is this similar to the base? Because think back. I told you anytime you have, y'all remember this? Anytime you have parallel lines, you have proportionality. Y'all remember doing that? Anytime you have parallel lines, you have proportionality between the sides. What if you have parallel planes? Do you still have proportionality? If this is parallel to the bottom plane, if it's parallel to the base, is this going to be similar to that every time? So I've never thought about it like that. That's pretty cool. If this is not parallel with the base, remember what it does though? If you kind of pull this down right here, if this is not parallel with the base, it's going to stretch that thing somewhat. But it'll just stretch it in one direction. It won't stretch it left and right. It would simply stretch it up and down there. So therefore, then you would not have proportionality. And then the last one, you have a cylinder on its side, and you chop off the top. You end up with a rectangle. And that's weird that you could actually end up with a rectangle from a cylinder. That's enough cross section. Let's start lateral and surface areas. And we've already discussed this. Lateral area versus surface areas. Lateral area is, well, I'm just going to read this. In a solid figure, faces that are not bases are called lateral faces. Faces that are not bases. The bases, we know base is what normally your figure sets on. When you're dealing with most shapes that have two bases, such as these, those bases a lot of times will be the same. In this case, your bases are hexagons. What about your lateral edges or your lateral faces? What are they? And most of the time will be. Most of the time your lateral faces will be rectangles. So lateral faces intersect each other at lateral edges. We all know what an edge is. The lateral face intersects the base at base edges. You don't have to know that. Pretty much just know what an edge is. Know what a lateral face is. Know what the base is. The height is the distance from base to base. And we all know that height must be perpendicular. Recall that a prism is a polyhedron with two parallel congruent bases. In a right prism, the lateral edges are altitudes. These are all heights. Right? Lateral edges are all heights. But in the oblique prism, notice an oblique. In an oblique prism, the lateral edges are not heights. Okay? The height, the way that you'd find height is go from the top straight down to the bottom. Good example, Leaning Tower of Pisa, right? Would be an oblique prism. It's not straight up and down, it's leaning a little bit. So that's what you got with an oblique prism. It's leaned over. Here we go. The lateral area. In order to find lateral area, you simply find the area of the sides, not the bases. You see here a piece of cheese, a triangular prism that has been cut apart. These three surfaces, or these three faces, are your lateral edge, or excuse me, your lateral faces. To find the lateral area, simply find the area of those three lateral faces, or however many lateral faces it is. Let's work the problem. Find the lateral area of the prism, round to the nearest 10. What shape is the lateral edges? Or lateral faces, excuse me. All three faces are rectangles. This is not setting on its base. Okay, this thing is setting on one of its lateral faces. The bases, guys, are those two triangles. So we're not looking for the area of those triangles. We're worried about finding the area of the three sides. Now let's take, and just on this problem, let's dissect those three sides. There's what you're finding the areas of. How tall are all three of them? Careful. 7. If it were setting on its bases, they would be 7 tall. All three of them. Now, what are the side lengths? What are the side lengths of 2 of them? 6 and 5, but we don't have the side length of the third one. How are you going to find it? We need that side length, don't we? Pythagorean theorem again. Okay? If you don't learn anything else, learn the Pythagorean theorem. You use it a lot. A squared plus b squared equals c squared. So take squared to get rid of it. I think it'd be the square root of 61. To be exact. Any questions on how I found that? So your lateral areas, the area of this is 42. Oops. The area of this would be 42. The area of this would be 35. The area of this would be 7 root 61. I can't multiply those, unless I turn it to a decimal. So final answer, we'll call it big L. Your lateral area is 42 and 35, which is 77 plus 7 root 61. That's exact. If you want the approximate, somebody's typing it in right here. Okay, go ahead and do times 7 now, and plus 77. 131.67. And let's talk about units here. You're finding lateral area, not volume. Finding lateral area. Area is measured in inches squared, centimeters squared, feet squared. This area is too. You're still doing area. Yep. When we get to volume, it'll be measuring something different. But when you're dealing with area, when you're wanting to cover this with paint, when you're wanting to put tile all over the sides of this, it's still in squares. Okay. Next one. The length of each side of the base of a regular octagonal prism. Let me explain what an octagonal prism is. I probably can't draw one. That's terrible. We all know what an octagon looks like. An octagonal prism is if you made that 3-dimensional. If you stretched it up, there's 2 bases just like this. It's going to be hard for me to draw. But if you stretch that up and made a prism out of it, and what a prism is any polyhedron to where the bottom and the top are the same shape. Whether the bottom and top are octagons, hexagons, squares, or rectangles. That'd be a rectangular prism. A triangle. Top and bottom are triangles. That'd be a triangular prism. So here the length of each side of the base of a regular, notice it's regular, so it means that all sides are 6. The height is 11. Now how in the world are we going to find that lateral area? I wish I had that 3-dimensional shape. So you've got this base, and you've got another base on top that looks identical to this, and then you've got all your lateral faces. Can anybody picture that? Anytime you have a prism, what are your lateral faces always shaped like? Rectangles. And what you've got, this is pretty much, imagine like this, these are your sides. You have, since it's an octagon on bottom, you have 8 of these sides attaching the bottom to the top. Each of these side lengths are 6 on bottom and top, it's a rectangle, and it says the height is 11. And since it's regular, that means all of them are identical. So to find our lateral area, well the area of this is 66. Now what do?
So you would multiply that times 8.
Yeah, times 8. Because there's 8 of those. So to find your lateral area, 66 times 8, 528 square inches. If you wanted to put tile on the side of all of those, it would take 528 tiles. 66 tiles per side. Surface area. Honestly, pretty much the same thing. The only difference between lateral area and surface area is when you're finding the surface area, you also find the area of the top and bottom. You're not worried about just the sides. First problem. Find the surface area of a rectangular prism. I'm not going to teach you. I'm not going to teach you formulas here. It's crazy to teach you formula. There's 6 surfaces. They're all rectangles. We know how to find the area of rectangles. Let's take the top and bottom first. We need surface area. We need the area of all 6 surfaces. Can anybody tell me the area of the top?
It'd be the same as the area of the bottom.
Yeah, it should be. Here's your top, right? This is 9, just like the bottom. This is 4, just like the bottom. So the area of that would be 36. How many are there? The top and bottom is the same, right? So can I do 2 times 36? Everybody good with that? Okay, let's go different color here. Let's go right side. What's the area of that right side?
24.
24. So I'm going to tack on 24. What about the left side? So times 2 of those. Now let's go front and back. Here's the front of this rectangular prism. What's the area of the front? 54. How many are there?
2.
Because the back is the exact same thing. Now there is a formula for the surface area of a, I don't know if it's on this last one. There's a formula that says it's something like 2 times length times width plus 2 times length times height plus 2 times width times height. Don't memorize that formula. You just did it. Right? Why is it length times width? Well, that length times width gives you one of the sides area. Why is there 2? Because front and back or left and right, they're the same. Length times height, that gives you the area of one of the others. So you know where the formula comes from now, so don't worry about memorizing it. Now, one formula I would do once you memorize, I want to go back to this. One way of finding surface area is using this. And you can write down either one. The surface area of a prism. Surface area is equal to the lateral areas plus 2 times the base, but I like the second one the best. Might want to write it. pH plus 2b. Make sure that the P is capital and the B is capital. pH plus 2b. Cool formula. pH plus 2b. And I'll show you on this next one that we just worked, how that works. pH plus 2b. pH plus 2b. First off, let's finish working this and see what our area actually is. 72 plus 48 plus 108. That's 122.28 square feet. Or you can use this formula. Surface area is equal to perimeter. Perimeter of the base. Now here's your issue. What's the base?
The square.
Can be. Well, there's no square. Okay. Little rectangle. What about the medium-sized rectangle? Or the big rectangle? They can be all. It does in a rectangular prism. It does not matter what your base is. Okay. Let's leave it as it's said. Let's let the base be the 9x4 rectangle on the bottom. So P right here stands for the perimeter of the base. Let's see if this works too. Surface area equals the perimeter of the base. Somebody do the perimeter of that for me? 9, 4, triple 13, and 13. 18 and 8, which is 26. I did it the other way. I did 13 and 13. You can do it 18 and 8 or 13 and 13. You get 26. Times the height, 6. Plus 2 times, okay, big B. This is real close to what I'm about to say. Big B in this entire chapter stands for the area of the base. Okay, big B here. Okay, the base, we let this be this 9x4, so that'd be 36. 26 times 6, 156, plus 72, which is 228 square feet. That works for all prisms. pH plus 2b. Okay. You know why? You know what pH does? That finds the area of all the sides. You know what 2 times b does? Finds the area of 2 bases. pH plus 2b. Yes. Yes, it does. Find the surface area. Let's use that new formula because I like it. Surface area is equal to PH plus 2D. In this case, Riley, what's the shape of the base? They'll say rectangle. It's not sitting on its base. It is a triangle. The bases are going to be your non-rectangular sides. When you're dealing with a prism, there's going to be two bases and they're going to be congruent. In this case, you have two triangular bases. Everybody see them? This is the base. Let me outline it. This is the other base. In all prisms, you have two bases that are identical. So imagine as we're going through this formula, that's your base. So surface area is equal to the perimeter of the base. How are we going to do that? We're going to have to use Pythagorean theorem. We're going to have to assume that that is a right triangle. It would be a 45, 45, 90. Thank you very much. That pops up so often, right? If this is a 90-degree angle, which we're going to have to assume it is, triangular prism, because that's going to be the only way you can work this problem. If that is a 90-degree angle, that has to be a 45, 45, 90. So making this side, let's do it right here. This third side would be 12 root 2. Learn that. So much easier. So the perimeter of the base would be 24 plus 12 root 2. We'll leave it like that for now. Times the height, how tall is it? It's going to say 12. If it were on its base, how tall would it be? 8. Everybody good with that? Plus 2 times big B, which is the area of the base. So do you see now why I said last chapter so important? You can still use, I'll let you use your formula sheet on this test. The base is a triangle. How do you find the area of that base, the area of that triangle? 1/2 times base times height. Now that's really confusing. What's big B stand for?
The area.
Area of the base. What's little b stand for? Just the base. Are we talking about the same bases? What shape is this big B? What shape is this big little b? A line. Big B and little b are not the same base. Okay? Big B is the area of the base, the shape. In order to have an area, it's got to be a shape. So big B would be stand for this triangle, the area of this triangle. Little b in this formula, 1/2 times base times height. 1/2 times 12 times 12. If you do that, I think you get 72. Area of the base is 72. So now we just work it out. If you want to do it algebraically, go for it. That's fine. I'll show you. I'll do it algebraically. But what you're probably going to do is type this in your calculator. Let's do it that way first. 24, well, here's my calculator. I'll just do it with you. And you can do it alongside me, check yourself, make sure you know how to do it. Let's do 24 plus 12 root 2. Which is that, times 8. Plus 72 times 2. Gives you 471.76. But if you want to impress all your friends, let's do it out there. I want the exact answer. And the problem is 24 plus 12 root 2, you can't add those together. What are we going to do with 8? What property? Distributed. 8 times both of them. 8 times 24, I think is, no, not 2. 192. 8 times 12 root 2. How do you multiply 8 times 12 root 2? Just 8 times 12. 96. Leave the root 2. Plus 2 times 72 is 144. Now what can you do with it? 192. Can you combine it with 96 root 2? You combine it with 144. Like terms. That's kind of like an x. Think about that as like an x on there. 192, 144 is 336 plus 96 root 2. Type that in. what you're going to get here kind of shows you, well, what if I don't understand all this algebra and I can get this decimal answer on my test, but it gives me this exact answer? It's the same thing. So if you get this exact, you come up with this and you don't know A, B, C, D, which one it matches, we'll type them in and see which one's equal to that. That's the easy way to do it. Lateral and surface area of cylinders. And you see how the chapter is going to progress. We pretty much just do all the shapes, lateral area, surface area, and then we'll go into volume. Lateral area and surface area of cylinders. Ignore all that first part. It's the same thing. The focus here, and by the way, cylinders are Coke cans. We know that. If you took and dissected one, not bisect, but dissect. If you took and dissected a Coke can, you cut the top off, you cut the bottom off, you cut a slit down the side of it, and you unrolled it. You got a rectangle. Does everybody understand that? And here's the cool thing about it. Look at the width of that rectangle. We know that the height of the rectangle is going to be the same thing as the height of the Coke can. But look at the width of the rectangle. This is where the formula comes from. The width of that rectangle is the exact same thing
As the circumference.
as the distance around that circle. Right? Isn't that how you get it to fold around the circle? Fold around the top of the can. It can be wide or further around than the can top. So therefore, the width is 2 pi r. So let's talk about how you'd find, well, first off, lateral area. How do I find the area of this side? This is the lateral. This is the side, the lateral face. The area of that lateral face, well, first off, the width we said was equal to the circumference, which is 2 pi r. The way that we find the area of a rectangle is to do width, length times width, which would be 2 pi r times h. That's the formula, 2 pi r h. Okay? Because it's the circumference times the height. Well, now what about surface area? Well, the surface area is simply the lateral area plus the area of the bases, because we've got to include those bases with surface area. The bases are circles, but there are 2 of them. There's the surface area formula. Surface area is equal to 2 pi RH plus 2 pi r squared. That is for a cylinder. Y'all need to write that down. Cylinder. You can do it on your formula sheet. I probably would. On your little formula note card. Hopefully you still got a back that's open that you can start putting formulas in. Now here's a formula that you don't see in books. But I'll give you a different version of that formula. You can use whichever one you want. Let's go back and review some algebra, because I know we all love algebra. Does everybody see that both of these have a 2? Both of these have a pi. Both of these have an r. You can factor. Never factor. Take these 2 terms. Pull out a 2, pull out a pi, pull out an r. What are you left with here? H. What are you left with here? 2, a pi, an r. This is an r times an r. There's an r. Because that's r times r, right? So if you pull out the 2, you pull out the pi, you pull out one of the r's, you're left with the other r. Does that formula look a little bit better? We'll make it look even better than that. What is 2 pi r? What's 2 pi r? Isn't that a formula for something? 2 times pi times radius.
Circumference.
There's a formula you never see in books. The circumference times h plus r. You can find, and we just derived that formula, you can find the surface area of a cylinder by finding its circumference, taking its height and radius and adding them together, and then just multiplying it by the circumference. That's weird. I know that's odd. That's totally off the wall, but I just want you to know we used a little bit of algebra. This is the formula you're going to see in all books, and this is going to be the formula you probably use on ACTs. And I'm going to use this formula for the problems, but then I'm going to turn around and I'm going to show you that this will work too. Pretty cool. That's different. So here we go. First problem. Find the lateral area and the surface area. Find the lateral and surface area. Let's start with the lateral area. Lateral area of a cylinder is equal to 2 pi RH. Hunter, is this cylinder sitting on its base? No. It's filled. Okay, the Coke's pouring it out. So you've got a cylinder setting on its side. 2 times pi. This is pretty easy formula, isn't it? Let's do it exact first. Notice I leave the equal. 2 times pi times radius. Hunter, what is the radius? 7.5. Times the height. Briley, is 15 the height? Because that's the distance from bottom to top, right? It's 15 the height. No. What's the height? 18. When you're finding the height of the shape, make sure set it back on its base. If this were sitting on its base, the height would be 18. So here we go. Multiply these in any order you want to. I'm going to do 2 times 7.5 first. Because honestly, instead of doing 2 times pi times radius, do you remember your other formula is actually pi times diameter? You could have done, instead of 2 pi r, you could have done pi times diameter times h. But 2 times 7.5 is 15. 15 times 18. Somebody have to tell me with that one.
15 times 18?
Yeah. Because we're going to do 2 times 7.5. Then we're going to do that answer times 18. Say again. And we're going to leave pi. If they ask for an exact answer, 270 pi's. I'd like to have 270 pi's. Or if they ask for an approximate answer. Because we know that as soon as you plug in anything for pi, whether it be 3.14, 3.14159, that answer is no longer exact. Because 3.14159 is not exact. How do you plug in exact, right? How do you write down the exact answer? You can't because it's irrational. It goes forever. What'd y'all get to 2 decimal places?
I got 842.
Point what?
23.
And that would be in millimeters squared. That is the lateral area. Now let's find the surface area. The only difference between lateral area and surface area is the lateral area is just the side. The surface area includes the top and bottom, the 2 bases. So let's do that first. Let's just do it like this. It'll be a whole lot easier. The area of the base is pi r squared. Pi times, what's the radius again?
7.
Don't type this in your calculator. Let me remind you of the shortcut that I told you a few weeks back. 75 times 75. Remember I've been showing you how to do that. It'll always end in 25. Remember that? 75 times 75, the answer will always end in 25. You take 7 and 8, the next number up. 7 times 8, 56.25, the 75 squared. But we're doing 7.5 squared. 56.25 is what you should get. All right. So you get as an exact answer 56.25 pi. That's the area of a base. How many bases does it have? 2. So you're going to do that times 2. So now here we go. Our surface area, let's do exact first, is equal to the lateral area. That's the area of the side, right here, plus 2 of those. Are those like terms? That has a pi. That has a pi. Sure. What's 2 times 56.25? You got that typed in there? 112.5. Geez, are they like terms? So that's kind of nice because we can leave it in terms of pi. 382.5 pi. That's exact. ACT is going to ask for exact. That's approximately
1,201.66.
And that's in millimeters squared. Now, if you wanted to, guys, the surface area is equal to 2 pi RH plus 2 pi r squared. Right? If you wanted to plug it into that, R is 7.5. Put a 7.5 everywhere you have an R. Put 18 everywhere you have an H and plug it in. What are you going to get? That same answer that we just got. That's 112 over 1.66. Let's see if my formula works. Circumference times, was it R plus H? Right. How do you find circumference? Pi times diameter. So what's this? Straight into my calculator. Circumference is equal to pi times diameter. So diameter is 15. So 15 pi times, what's R? Plus H. Same answer. Is that quicker? I think so. I think you refer to that as Swinford's formula. That's the name of it. Next problem. Let's work this one. I'm going to work it the long way. I'm just going to do surface area, lateral area. Anytime again, I'm not going to do it, but anytime you look for lateral area, it's going to be simply 2 pi r h. But to find surface area is equal to 2 pi r h, or you can replace that with pi d if you want to, plus 2 pi r squared. So let's show you how to plug this in. Surface area is equal to 2 pi times 5 times 9 plus 2 times pi times 5 squared. And honestly, from here down, please excuse my dear salary. You have two options. And all depend. Look at your 4 answer choices, or if it's multiple choice, or if it's ACT, look at your 5 answer choices. See what they look like. If they are decimals, what do? Type all this straight through your calculator, and it's going to give you decimal answers. If they are exact, what do? Leave pi. Let's try to do it that way. 2 times 5 times 9 is 90, leave pi. Plus 2 times 5 squared, what's that? 50, leave pi. 90 pi plus 55, that's 140 pi's. If they leave your answer as exact, that's what you're going to get. So very good. If they give you a decimal as an answer, you could just multiply this by pi, or you could have just right here typed all this straight in. That's what I was going to go for. 2 times pi times 5 times 9 plus 2 times pi times 5 to the second power. You get 439.82, which should be the same thing if we did it right as 140 pi's. Okay? Either way. Or, and we're not going to work that second one. Or you can use the Swinford formula. That's what S stands for. S is equal to circumference times R plus H. Circumference is pi times diameter. The radius is 5, the diameter is 10, so that'd be 10 pi. Times R plus H. What's R plus H? 10 pi plus times 14. 140 pi. Either way. Next problem says find the diameter. Because we've been finding surface areas. We've been finding lateral areas. Now it says find the diameter. If the surface area is 464 pi. Find the diameter of the base of a cylinder if the surface area is 464 pi square centimeters and the height is 21. Start with your surface area formula. Surface area is equal to 2 pi r h plus 2 pi r squared. And we'll work it with my formula too and see if we can do it with this. The surface area is 464 pi. The height is 21. Can we clean that up? Can't we multiply 2 times 21? Sure. Since all this stuff is being multiplied together, you can multiply in any order you want to. Let's go ahead and do 2 times 21. It gives us 42 pi r plus 2 pi r squared. let me show you a trick. And I'm getting into a lot of algebra here, but it's good to review algebra and geometry. How many terms are there? 3. 464 pi, 42 pi r, 2 pi r squared. There are 3 terms there. Is there anything common to all 3 of those terms? They're all 3 have a pi. Let's go back to fractions. 7 over 21. How do we reduce fractions? Is there anything common? What number's common? 7. 1 over 3. We divide by that common factor. Did you say anything was common here? You know what you can do, guys? The same way you reduce fractions, you can reduce equations. Let's reduce this equation. Let's divide everything, every term by pi. They'll cancel. You can dump all the pi. Looks a little bit better, right? You know what it looks like to me? It's quadratic. You might not have noticed that to begin with. This is a quadratic equation because you have r squared, you have r, and you have a constant. It'll reduce one more time. Is there anything else common?
2.
2. 232 equals 21r plus r squared. It looks a little bit better. Since it's quadratic, let's go ahead and solve it. Let's get it in the right form. You're used to seeing it as r squared plus 21r, right? Move the 232 over, minus 232 equals, I'm going to put the equals at the end, equals 0. You have a quadratic equation. Never forget how to solve quadratic equations. They pop up all the time. You can try to factor it. You have 2 methods of solving quadratic, two reasonable methods. Try to factor it. If it doesn't factor, use quadratic formula. That's your best bets. Factoring. We ask ourselves what multiplies to give us r squared to be r and r. Then we ask ourselves what adds to give me 21, multiplies to give me negative 232. That'll take a while. Here's my method. I know that's an even number, so I know that 2 times something, let's see, I think it's 116, will give me that. I'm not good with 21 though. And then I use what I call the double and half method. Double the first number. Let me do this in a different color. Keep it separate. 2 times 116. Double the first number, half the second number. That's 58. Still ain't good. Double the first number, half the next number.
458.
You see how I did that? Doubled and halved. Doubled and halved. 8 and 29. Isn't that a difference of 21? There you go. We need to multiply to give us a negative 232. So one of these has to be negative, one of them has to be positive. And they have to add to give me a 21, so which one's going to be positive? Plus 29 minus 8. So our 2 solutions are, which by the way is the radius, can either be negative 29 or r can be positive 8. I would go with 8. The radius cannot be negative. So r is 8. Any questions? Let's try my method. Let's try my method. Let's clear all that. Surface area equals, let's wait for method, circumference times r plus h. It might not work, honestly. It might not. 464 pi equals circumference times r plus 21. Yeah, I think it's going to be just as easy the other way. Because your circumference, you're going to have to plug in like pi d or something there, or 2 pi r, and you're going to end up with a quadratic. So you would have 464 pi equals, circumference is 2 pi r times r plus 21. Yeah. You would divide by 2 pi, which would give you 232 equals r squared plus 21r. It's the same. It'd be the same equation. So you're going to be working it the same way. Last one that we're going to work today. Regular pyramid. A regular pyramid has a base that is a regular polygon. Here it's a square. It could be an equilateral triangle. It could be a regular pentagon. It could be a regular hexagon, a regular heptagon, octagon, but it has to be regular. A regular pyramid has a base that is a regular polygon and an altitude, and the altitude has an endpoint at the center of the base. There's the altitude of the height. And then you've got what's called a slant height. And I want you to focus on something about that slant height. The slant height goes from the top down to the edge, not down to straight down to the bottom, but it's perpendicular with the edge. That slant height will actually be the height. If you took this triangular edge or this triangular face and you stood it up, the slant height would be the height of that triangle. So that's the reason that's going to be important to know. Here's your next formula. The lateral area, that's the side area, the lateral area of a regular pyramid. The lateral area is equal to 1/2 times P times a cursive L. The lateral area equals 1/2 times P. P is the perimeter of the base times times the cursive L, which is the slant height. These are pretty easy. The lateral area is equal to 1/2 PL. 1/2 times the perimeter of the base times the slant height. You see how fast this is going to be? Let's work at the argument first. The lateral area, okay, the lateral area does not include the base. You're not going to find the area that square on bottom. The lateral area is the area of those four triangles. The area of a triangle is 1/2 BH. The base of that side triangle is 4. The height of that triangle is 6, so that's going to be 12. And here's the reason we have to go with regular. Since this is a regular quadrilateral, also known as a square, since this is a square, then all four of these triangles on the sides will be the same. So what's going to be the lateral area? 48. But look how much quicker this is. The lateral area is equal to 1/2 times the perimeter of the base, all sides are 4, times the slant height. I do 1/2 of 16, and then I do times 8, which is 48 inches squared.